Hello guys, good morning. You are welcome to my YouTube channel, the Explicit Tutorials. My name is Son Joseph. In today's video, I'll be taking us a topic called Alkanes and Alkenes in Chem 113 chapter 5 to be precise. After this chapter, we'll be left with two chapters to be done with the semester. Now let us start with what? Alkanes. Okay, let us start with how alkanes and alkenes are prepared. Okay, let us start with alkanes. And preparation of alkanes. And of course, you know that another name for the alkanes is called what? Paraffins. Alright, another name for the alkanes is called what? Paraffins. They are otherwise called what? Paraffins, because they show a little affinity to certain reagents. That is, they are chemically what? Inert. They only react under certain what? Condition. I know that methane is an exemption. Methane is a very volatile gas. It is found in swampy and marshy places. It is very, very volatile. Hence, it's called what? Marsh. The other name for methane is called what? Marsh gas. It is very volatile. They are paraffins because they show little affinity towards certain reagents, and they are chemically what? Inactive. They are inert in nature. So the simplest form of alkanes are actually the methane, the ethane, the propane, and what? The butane. Please, the principal constituent of cooking gas is what? Methane. The principal constituent of cooking gas is what? Methane. Now, how are alkanes prepared? Now, alkanes are prepared through one, the catalytic hydrogenation of unsaturated hydrocarbons. Of course, owing to the presence of one sigma bond, or owing to the presence of just one bond in alkanes, that is what's responsible for their high degree of what? Saturation. Hence, they are called what? Saturates. Because of the presence of one bond, they are saturated. They have high degree of what? Saturation. And as for the alkenes, they are not saturated because of the presence of what? Two bonds. Okay, and I said alkenes are prepared through what? Catalytic hydrogenation of unsaturated hydrocarbons. Now, if I don't want to use this long name, I can simply say what? Addition reaction. This is a type of reaction that occurs in the presence of what? Catalysts such as nickel and platinum. Look at it. Unsaturated carbon, which means we are going to be adding hydrogen to alkenes and alkanes to produce what? Alkanes. Sorry, unsaturated. We are going to be adding hydrogen to alkenes and alkynes. Look at it this way. I have CH2 double bond CH2. This is what? Ethene. Then plus H2. Don't forget, in the presence of what? Nickel or what? Platinum. In doing that, I'm going to this C2. Alright, this C2H6. So this is what? An ethane. Look at the word in. But this one is what? Ethene. In. Alright. Now, if I have CH triple bonds CH, this one is what? Ethyne. Because of this word, triple bonds. Don't forget plus H2. Nickel is acting as a catalyst or what? Platinum. In doing that, I'll now have what? C2H what? 6. This is what? An ethane. Alright. So is it balanced? 6. So I'll put 2 here. So it's not balanced. 6 hydrogen atoms. 2 plus 2. 1 plus 1, 2 plus 4. That is 6. Then 2 carbon atoms. So it is balanced. Catalytic hydrogenation of what? Unsaturated hydrocarbons. So that is for that. Ethane is also prepared, or alkane is also prepared when sodium acetate is reacted with an alkali. Look at it. When sodium or potassium acetate is reacted with what? An alkali, like sodium hydroxide. Look at, I now have CH4, like you have CH3 there plus this one, I have what? CH4 plus what? Na2, that is sodium carbonate. Alright, which means that an alkane called methane can be prepared from what? Reacting an alkali. It could be sodium hydroxide or potassium hydroxide with sodium acetate or potassium what? Acetate, as the case may be. Okay, now please, during this process, please, soda lime is prepared to what? Caustic soda, because it is non-deliquescent and it does not attack what? Glass. Soda lime is a combination of what? Sodium hydroxide and calcium oxide. Soda lime is a combination of what? Sodium hydroxide and what? Calcium oxide. The soda lime is preferred to using caustic soda because it is what? Non-deliquescent and it does not attack what? Glass. So those are the two criteria why soda lime is preferred to what? Caustic soda. Please, as Jambite, take note of that. Okay, now number 2, reaction of sodium acetate, or sodium ethanoate with alkali, could be sodium hydroxide or potassium hydroxide, to produce methane and what? Sodium carbonate. Now number 3, I can also prepare alkane from the reduction of ethyl halide. Alkane can also be prepared from, that is number 3 now, reduction of ethyl halide. Ethyl halide is, now I'm reacting it with what is called nascent hydrogen. All right, nascent hydrogen in the presence of, now listen to this. During the reduction of ethyl halide to produce an alkane, it's either we use zinc or copper in an acid. In doing that, I'm going to be having, you have hydrogen, I'm going to be having ROH. I've taken one H from here, right? That is ROH. I've taken one H from here. I'm left with HX. Now this X is the halide. This X is the halide. This X could be bromine, iodine, chlorine, or whatever. It becomes what? If this Ra presents CH3. If I had wanted to use any of those halogens of halides, I can simply put Cl here instead of writing X, then plus what? H2. The same thing. I'll now be having, if I take one from here, add it to this place, I'll have what? Methane. So indirectly, this guy here is what? An alkane, methane. Then this Cl will now join the other H remaining here, becomes what? Hydrogen chloride. You can see that. So if it was I, it becomes what? Hydrogen iodide. So that is it. The reduction of ethyl halide in zinc or copper dissolved in acid to produce what? An alkane and what? Hydrogen halide. So that is for that. If I don't want to, if zinc or copper in acid is not used, we can also use let me use the normal procedure. Let me use iodine plus H. We can also use two powerful reducing agents, which are sodium tetrahydroaluminate 3, by sodium tetrahydroaluminate 3, or sodium tetrahydroborate 3. You can use this or this. In doing that, take one H from here, add it to this, it becomes what? CH4, then plus, then I'm left with what? 1H, it becomes what? HI. This what? This an alkane called ethane. This an alkane called ethane. So this is what? Hydrogen iodide. Hydrogen iodide. So this X could be Cl, could be chlorine, could be bromine, could be iodine. When it's bromine, it becomes hydrogen bromide. When it's iodine, it becomes iodine iodide. When it's HCl, when it's Cl, it becomes what? Hydrogen chloride. So that is how it is. No, so which means that reduction of an alkyl halide will produce what? An alkane called what? Methane. Take note of that. Number 4, we can also prepare an alkane from Wood's reaction. From Wood's what? Reaction. This reaction involves reacting double, that is reacting hydrogen. Okay, no, not nitrogen now. Wood's reaction is a type of reaction in which two alkyl halides are reacted with what? A metal. It could be sodium, it could be potassium. And this it occurs present of what? Ether. So ether is acting as what? The catalyst in this reaction. Wood's reaction is a type of reaction in which two halide, that is two alkyl halide, are reacted with what? A metal of, okay, a metal. It could be sodium, it could be what? Potassium, it could be silver, as the case may be. Now, in doing that, I will now have you have two methyl group becomes arrow. Then what am I left with? Sodium halide. That is sodium halide. Now this arrow means CH3 CH3. CC is what? C2. Then this plus this is what? 6. So this is what? An ethane. You can see now that during Wood's reaction, an alkane called ethane is what? Produced. So please take note of that. During the process, ether is acting as what? The catalyst. Okay. Now we can also prepare alkane from Grignard reagent. Grignard reagent. You know, I told us in our previous class that Grignard reagent is an organomagnesium halide. An organomagnesium halide. When organomagnesium halide is decomposed with water or an acid, you know, if I should break this water into two, it becomes what? H plus and what? OH minus. Okay, which means that when Grignard reagents, which is what? An organomagnesium halide, that is Grignard reagent. Let me spell Grignard reagent. When it's decomposed with water, it will form, I want to take one R from here, that is now one H, sorry. This H will combine with this, it becomes arrow H. Then plus, I'm left with OH and MgX. So it becomes Mg open bracket OX. Alright? Which means that this magnesium hydroxy halide. Magnesium hydroxy halide. Now look at this arrow, this H has combined with this. There's a reason I'm taking it bit by bit, okay? This H, one H is combined with this. You now have what? This methane, as earlier said. So I'm left with what? OH. This OH will combine with this to produce what? This. Which means that Grignard reagent, when decomposed with water, will produce what? An alkane. Okay, take note of that. We can also prepare alkane from this should be number 5, if I'm not mistaken. Should be number 5. I don't know. Number 6. From Cobb's electrolytic reaction. From Cobb's electrolytic reaction. In this type of reaction, sodium or potassium salt of carboxylic acid is what? Being reacted with water. Look at it here. If I have CH3 O ONA. Now this was sodium acetate, that is salt, sodium salt of what? A carboxylic acid. If I should react it with water, don't forget H plus OH minus. Now what would happen? I'm going to be having a methane, CH4. Like this H will combine with this, and now what? CH4, then plus carbon 4 oxide, CO2 plus, now I'm left with what? OH. OH will combine with this one, with this sodium, becomes what? Sodium hydroxide. So the reaction of salt of carboxylic acid with water is called which of these? They'll give you Kolbe reaction, they'll give you Kolbe's reaction, they'll give you Ward's reaction, they'll give you Wheaton reaction. Please, it's what? Kolbe reaction. Wheaton reaction is alkene. So I can also do the same thing here, like CH3O, then OK, like K now not sodium anymore, plus what? Water, H plus OH what? Minus. Okay, definitely CH4 is produced, carbon 4 oxide, then potassium what? Hydroxide, plus potassium hydroxide. So these are the various ways in which you can prepare alkane. The first one is what? Catalytic hydrogenation of what? Unsaturated hydrocarbon. Two, I said that when sodium acetate or sodium ethanoate or potassium ethanoate is reacted with an alkali, it will produce sodium carbonate and what? Methane. Then number three, I said when an alkyl halide is reduced in the presence of sodium tetrahydroaluminate 3 or sodium tetrahydrobromate 3, or when zinc or copper are dissolved in what? Acid, they can actually reduce alkyl halide to what? Methane. Alright, I also said that we can also prepare alkane from what? Grignard reagent. That is the art of decomposing Grignard reagent with what? Water to produce this. So that is for that. Then Kolbe's what? Reaction. So we have come to the end of the preparation of what? Alkanes. Preparation of what? Alkanes. The next one is what? Preparation of alkanes. So in our next video, I'm going to be telling us the reaction of alkanes and alkenes. What kind of reaction do they undergo? Hope it's recording. Thank God it's recording. What kind of reaction do they undergo? Okay. Now I have alkene. Alkene is otherwise called what? Olefin, or alkenes are otherwise called what? Olefins. They are called olefins because they produce oily substance when they react with what? Chlorine. They produce an oily substance when reacted with what? Chlorine. That's why they are called what? Olefins. Now, how do we prepare alkenes? One, through dehydration reaction. Dehydration what? Reaction. Now, when ethanol is dehydrated, C2H5OH, in the presence of an acid called what? H2SO4, which means that during dehydration reaction, the catalyst acting as a dehydrating agent is what? H2SO4. That is, we want to remove water from these idiots. In doing that, I'll take one H from here. I'll be left with what? C2H5. Okay, C2H4. If I should combine that H that I've taken, if I should add to this, it becomes what? H2O. That is H2O. Alright. Now we've successfully prepared what? Anethene. This is what? Anethene. However, if excess amounts of alcohol is dehydrated, it will not produce ethene. It will produce an alkoxy alkane. Like if I have 2C2 H5OH. I'm going to be having something like this: C2H5O, then C2H5. Now this is what you have: two ethyl group. It becomes diethyl what? Ether. And this is otherwise called what? Alkane. Please, the dehydration of a molecule of alcohol will produce ethene and water, fine. But the dehydration of excess alcohol produce an ether, an alkane called diethyl what? Ether. Take note of that. Now we can also prepare alkene through the dehydrogenation. We can also prepare alkene through what? Dehydrogenation. That is the reverse of what? Addition reaction. You have, when I was taking the preparation of alkanes, I did something like this: C2, I said it occurs in presence of nickel, platinum to produce C2H6. That is how alkane is what prepared. Now the reverse of this addition reaction is called what? Elimination reaction. I want to remove what? Hydrogen from here. That is dehydrogenation. Dehydrogenation. Alright, this hydrogenation, we are adding hydrogen, but removal of hydrogen is called dehydrogenation. So I'll bring this idiots. C2H6. I want to remove two molecules of hydrogen from here. Becomes C2H4. That is minus H2. I've taken 2 from here, so I'm left with this ethene. You can see from dehydrogenation we have successfully prepared what? An ethene. We can also prepare ethene through dehydrohalogenation. Dehydrohalogenation. In dehydrohalogenation, this is number 2, number 3. Dehydrohalogenation, that is, we are removing hydrogen and what? Halogen. Hydrogen and what? Halogen. Could be bromine, could be chlorine. Let's do it. And it occurs in the presence of what? Caustic soda, potassium what? Hydroxide. If I have C3H7Br in the presence of what? Potassium hydroxide, I want to remove hydrogen and bromine. That is hydrogen and what? Halogen. If I remove one hydrogen from this H7, it becomes C3H6, and this is what? Propene. You can see that we have successfully prepared what? Alkene. So I'm left with what? I now have what? Potassium bromide, right? Okay, not just that. Okay, I've removed HBr. Then I'm left with what? H. That is OH, and that HI2 becomes what? Plus what? Water. Alright? So plus HBr. This is HBr, that is hydrogen bromide that was removed. Water is formed, and propane is what? Formed. That is dehydrohalogenation. Please take note of that. We can also prepare ethene from dehalogenation now. We can also prepare, please, I'm busy. We can also prepare ethene through dehalogenation. That is number 4. Dehalogenation. That is removal of what? Hydrogen and what? Bromine. So let's do it. It becomes, if I have CH, who is that? I'm busy. I'm coming. CH, if I have CH3, CH2. Okay, maybe if I have, okay, let me just like this. C3H7Br. I want to remove bromine and what? Hydrogen. It becomes I want to remove one from here. Like, please, during dehalogenation, this reaction occurs in the presence of zinc in dust. That is dehalogenation. It occurs in the presence of what? Zinc in what? Dust. In doing that, I now have C3H C3H6 plus zinc bromide. So we are successfully produce what? An ethene. Okay. Now the next one is what? The last one, which is Wheaton reaction. Let me quickly round off. Wheaton reaction. This is a reaction between aldehyde or ketone, and if I have this arrow, double bond, this is what? A ketone. If I should react it with a phosphorine, like arrow, BPH3. Okay, I will have this, cut. This will combine with what? This. So I'm left with what? This and this, then plus PPH3PO. So this guy is called what? Phosphorine. When phosphorine is reacted with that is ketone, it will produce this ethene. So this other guy is called what? Triphenyl phosphorine oxide. All right. So at this point, to call it a day. Thanks for watching and endeavor to subscribe. Yeah.